Okay, pre-calculus, in this video we are still looking at our vector unit 9.3 and we are looking at example 4 in our notes, more speed and direction, but this time it's going to be a little bit different. So we have an orienteering competition and Tia walks north 50 degrees east for 120 feet and then she walks 80 feet due east. How far and at what quadrant bearing, so we are looking at a directional bearing here, not a true bearing, is Tia from her starting point? All right, so we want to know how far she travels and what her new quadrant bearing is when she ends up at her final destination. So obviously we don't have her walking speed here. We are going to use the distance she traveled in place of magnitude in our velocity vector, which is totally okay because the magnitude is actually the distance anyway. It's the length of a vector. So that should make perfect sense. So the first thing I'm going to do is draw a picture. All right, so we are told that Tia walks north 50 degrees east. So I'm just going to draw this right here. Okay, it probably doesn't need to be that outrageously long. So I'm going to measure 50 degrees in this direction. Okay, so that is north 50 degrees east. Okay, so there's her first leg, and that is 120 feet. And then she walks due east. That means straight east. Okay, and that is for 80 feet. And then we want to know how far and at what quadrant bearing Tia is from her starting point. So that's going to be this right here. So I am going to create the relationship here. So I'm going to use the mathematical relationship of all of my velocity vectors. And so I am going to just let this one be V and this one be W. It doesn't really matter which one is which since we're not dealing with subtracting. All right, so V is going to be 120 times the cosine of the direction angle. Well, the direction angle starts positive x and goes here. So that's going to be 40 degrees. So V, when I type this into my calculator, gives me 91.9 and 77.1. So there's V, so now we need W, which is the other leg of her journey, and that is 80 times the cosine of, well, we need our direction angle. Well, since this is due east right here, that means it's just 0 degrees. What? I know, right? Okay, so when I type this into my calculator, I get 80 and 0. That should make sense to you because remember in your unit circle right here, this ordered pair is at 1, 0. So that should make sense to you. All right, so once we get these, we are then going to combine them to get R. So I'm going to have 91.9 and 77.1 plus 80 and 0. So my resultant vector is 91.9 plus 80. So that's 171.9. And then, of course, 77.1 plus 0 is just that. Okay, so basically what's happening here is I've got 171.9, 77.1. See, I've made my little right triangle with this. All right, so once I do that, this right here now is going to be theta. So I'm going to use tangent theta, just like always, opposite over adjacent. Remember, in your calculator, you type in tangent inverse of all of this, and for theta, we get 24.2 degrees. All right, so this is her ending spot right here, and this is her beginning spot. So if we can calculate the bearing to this right here, it's going to be north this many degrees east. All right, so all I have to do is calculate that many degrees. Well, if that's 24.2 degrees, then it's going to be 90, the whole quadrant, minus this, and that will give me this value right here. So when I subtract 90, or when I subtract 24.2 from 90, I get 65.8 degrees east. And that is my quadrant bearing. Awesome. And how far has she gone? Well, I need to use my distance formula for that. And I'm just going to use this right here. So 171.9 squared plus 77.1 squared. And taking the square root of that, I get 188.4 feet in total. Nice.